most of it comes out as vibrations, which travel through the rock. And a couple things we talk about in technically when we're talking about earthquakes. The epicenter is the point on the Earth's surface directly above where the earthquake occurs. So we'll talk about epicenter plots when we show some data from McAdam soon. And when an earthquake goes off, it emits a few different types of seismic waves, and we'll show that. That relates to how we locate earthquakes. This is just another graph of the idea of, again, of oftentimes the incredibly sensitive, incredibly high fidelity sensor in there, a seismometer called a very broadband seismometer. And the little box in the bottom left is a strong motion accelerometer. It's made to detect, and without it exceeding its range, detect strong events. And there's a seismic recorder and then the internet link. So the data, both sets of data are actually being sent out to Ottawa in real time. It's time, and you can see the vibrations coming in as a function of time. The first wave that arrives is called a P wave. It means primary wave. It's the first arrival. It's traveling. I've got this link again. It travels like a compression, just like an air wave travels through the air. The second type of wave is a shear wave, and it moves the rock back and forth as it propagates that way. It's a bit slower, and the third type is a surface wave. And we actually looked, March the 30th, just 2 weeks ago, in Bathurst area. And I'm showing you the recordings that were made in Bathurst. That's the first traces at the top. So that's up, down, north, south, east, west in Bathurst. And this is the traces made in recordings in the basement of the residence over in northern part of McAdam. And these are measurements made in Maine, all from the same earthquake. Oh. And you can see the arrival of the, go ahead, Ken. You can see the arrival of the P wave and the S wave here in McAdam from that Bathurst earthquake. So it just shows you, that's the raw data that's being sent out continuously to Ottawa for analysis by the seismologists. Yeah, this is illustrating the difference between a P wave and an S wave. So if you were to take a Slinky layout and you pluck it, the wave, sorry, at 1:40 in the morning on the night of March 10th. Yeah. So that just shows you a seismogram from basically a whole day of records. So each line is an hour. The colors mean nothing. It just helps you to see one line to the next. And here's the main shock plots. Sorry, I shouldn't call it the main shock. The first event plots just east of the center of town, and the others were distributed, or kind of scattered around. But the scales at the bottom left are kind of within north-south. It must be what
in the Arctic, again along Pike Margin. But we do have a collection of earthquakes down here along the east coast in New Brunswick and down into New England. So next slide, look at the distribution of earthquakes in New Brunswick since 1980. You can see there's a fair scatter, but the larger earthquakes all tend to occur.
I think the way you try to get at that is plotting up the if there are more events. You continue.
Is there somewhere we can go on, find out what you're doing safely? How long are you going to test it for? Years, 6 months? You know what I mean?
All right. How long the monitoring is going to stay in place? That's an open question, I guess. Really, that was really most of the instrumentation belongs to natural resources.